Hi everybody. In this video, we're going to look at the roots of the equation f of x equals 0. So if we have f of x, the roots of this equation are where the curve intersects the x-axis. And sometimes, when we can't solve f of x equals 0 algebraically, we need to use a numerical method. So what we do is we pick a value of x either side of this root. Let's say in this point, when x equals a, and we pick another point on the other side. Let's say in this point when x equals b. So if we look at when x equals a, we can see that f of a will be negative. This will be less than 0 because it's below the x-axis. And if we look at f of b, this will be greater than 0 because this is above the x-axis. So if we have a change in sign between x equals a and x equals b, and the curve is continuous within this interval, then there must be at least one root for f of x equals 0, okay? And it works on the other graph as well. If we pick this point, when x equals a, you can see that f of a, this time is greater than 0. And if we pick this point, when x equals b, you can see that f of b, this time is less than 0. So we've got a positive solution at x equals a, a negative solution at x equals b. So again, we've got a change in sign. And you can see that the graph is continuous within that range. So we can say there must be at least one root when f of x equals 0. So the way we write this is there is a change of sign between x equals a and b, and the curve is continuous within that range. Therefore, there must be at least one root to f of x equals 0. So we need to create a written statement like this when there's a change of sign and the curve is continuous. But in the special cases we need to consider, we have to be careful when we choose our values of x. Say for instance we choose a value of a on this side and a value of b over here. Well, we can see that f of a is greater than 0 and f of b is greater than 0. So you might conclude that there's no roots, but actually there's an even number of roots within that range. So we have to watch out for an even number of roots. There's another case, if we choose this value of a and this value of b, again, f of a is greater than 0 and f of b is greater than 0. So again, you might conclude there's no roots, but actually there is one root. It lies on the axis. So this is when we have a single root that touches the x-axis. So we need to be careful of this situation as well. And the third condition, if we pick this value of a and this value of b, well, f of a is less than 0 and f of b is greater than 0. So you might conclude that there is a root. But you can see that the curve is broken between the 2 points. So what we say is, there is no root between a and b because f of x has discontinuity. You can see that the curve is not continuous between this point. Here it shoots off down to negative infinity, it's undefined, and here it shoots off to positive infinity, again it's undefined. So this happens when you divide by 0. So as we progress through this video, we'll be looking at how we can locate roots on the x-axis while we consider these 3 special cases. Let's try example 1. In our first example, we've been asked to sketch a graph to show that this equation has exactly one solution. But this is quite a difficult equation to sketch. But what we can do is, if e to the x plus x minus 8 equals 0, we can move the x and the negative 8 over to the right hand side. So e to the x will equal 8 minus x. So if we sketch the graph of each of these, when they intersect will be the solution to this equation. So I'll sketch a pair of axes. If I sketch e to the x in red, we know e to the x would look something like this. And if I sketch 8 minus x in green, that will look something like this. We know the y-intercept for e to the x is 1, and for 8 minus x, we have 8. And the x value will also be 8 as well. So we know there's only one solution to this equation because the two graphs only intersect at one point. And we've been asked to show that the only root of the equation lies within the interval of x equals 1 and x equals 2. And I want to show you how to do this on a calculator. So we'll go to our calculators and we're going to create a table. So we'll press mode or home and we'll go down to table. Now we're going to enter in this equation. So we press tools, we're going to define f of x and we enter e to the power of x plus x minus 8. And now we can just enter 1. We want when x equals 1. And you can see that f of 1 is negative 4.281. Now if we let x equals 2, then f of 2 is 1.389. So you can see there's a change of sign between the two, and the curve is continuous within that range. So we can say there's a change of sign between x equals 1 and x equals 2, and the curve is continuous within the range, therefore there must be at least one root in this interval. And we can find this root to one decimal place. If we go back to our calculators, if we press tools, and we want to define the table range, we know it's between 1 and 2, so we'll start at 1, we'll end at 2, and we want the step of 0.1. We want the solution to one decimal place. We'll execute this, and you can see f of x is negative, continues to be negative, but is approaching 0. And then when x is 1.8, we get negative 0.15. And when x is 1.9, we get 0.58. So if I screenshot this, when x is 1.8, we get negative 0.15. And when x is 1.9, we get 0.586. So the solution to one decimal place is that x equals negative 0.15, because this is closer to 0 than this one is. Okay? Let's try one more question. So do you want to read through this question yourself and give it a go? You can pause the video and come back when you're ready. Okay, so I'll come back if you're ready to go. So to sketch the graphs, I'll sketch the natural log of x in red. That would look something like this. This will have a root at positive 3, and that will look something like this. So we've got y equals the natural log of x, and y equals x minus 3 squared. And this will be at 1 here. So we know at each of these 2 points, the natural log of x will equal x minus 3 squared. If we move this over to the left-hand side, the natural log of x minus 3 squared will equal 0. And we're told there's a solution to this between x equals 2 and x equals 3. So if we go back to our calculators, we'll press tools, we'll define our new function of x. This is the natural log of x minus x minus 3 squared. We'll execute that. I'll delete these old values. We'll enter x equals 2. So f of 2 will be negative 0.306. And we'll enter x equals 3. And we get 1.10. So we can say there's a change of sign between x equals 2 and 3, and the curve is continuous within that range. But we need to find it to one decimal place. So if we go back to our calculators, we'll go to Tools, we'll define our range between 2 and 3. I'll screenshot this. So when x is 2.1, we get negative 0.068. And when x is 2.2, we get 0.1484. So our solution is that x equals 2.1 to 1 dp. You can see this is closer than 2.2. Okay? Well, thank you very much for watching. I hope you found that useful. If you want more practice on this topic, you can download the worksheet and view the online lesson from my website, mrmathematics.com. I'll leave a link in the description below.